Okay, so we're gonna talk a little bit more about functions today. We had a really long lecture last class. Today's gonna be a lot shorter. We're gonna talk about getting some information from the graph of a function and interpreting functions. So first thing we're gonna talk about is increasing and decreasing. So if the values of f of x, which you can read y, right? F of x is just our new notation for what we used to call y. If the values of f of x increase, are getting bigger, if the y values are getting bigger as the x values are getting bigger, we say the function is increasing on the interval. So this piece of the graph right here, I would say is increasing. Okay, you can also think of it as uphill. If you're walking left to right on the graph, if you're walking uphill, the function is increasing. If the values of f of x, that is the y values, get smaller as x gets bigger, we say that the function is decreasing on the interval. So right here, my function is decreasing. It's downhill. And if the values of f of x stay the same on an interval, we say the function is constant. So this piece right here is constant. So for this particular function, I would say f of x is decreasing on the interval from a to b. So when you explain where a function is decreasing, increasing, or constant, you just give x values. So I would say that this is increasing on the interval a to b. And I would say f of x is constant on the interval from b to c. Okay, so again, I just give the x values of where the function is increasing, decreasing, or constant. Yeah, question? Yeah, this is one of those things that's kind of the convention varies from textbook to textbook. Our textbook closes both of them, but I won't mark you wrong because it's not one of those things that's been absolutely decided by the math world, right? So our textbook puts closed brackets on both things, but you should probably, if you're going to use WebAssign, you should do it that way because that's how WebAssign uses it. On a quiz or a test, I won't take points off if you do it wrong or not the way the book does it. So f of x, I would say, is increasing on the interval from c to d. Does that make sense? Downhill is decreasing, uphill is increasing, flat is constant. And when they ask you where a function is increasing or decreasing or constant, you give x values. So here's an example. Discuss in your groups. I want you to write down what intervals this function is decreasing, increasing, or constant for. Let's discuss the results here. So first, let's talk about decreasing. So I want to know what interval this function is decreasing on. -4 to 2. Yes, so from here to here, this function is going downhill. Now, when you answer on what interval is it decreasing, you just give the x interval. So I would say from here to here, this is the interval on which the function is decreasing. So -4 to 2. And then for increasing, I'm definitely increasing 2 to 5. Yep, from x equals 2 to x equals 5, I'm increasing. And where else? -infinity to -4. And I'll put a union because it's both of them together are increasing. How do you feel about it? Okay, do the next one. Okay, where is this function decreasing? Negative infinity to negative 3. Yep. So this part of my function is decreasing. And I only give x values. So negative infinity to negative 3. Where else? 4 to infinity. Okay. And then where's my function increasing? Negative 3 to 0. And constant? 0 to 4. Seems like you guys got this down. Great. Okay, so here's a little bit more vocabulary. So we just learned 3 things: increasing, decreasing, constant. Here's a couple of other little vocab things. We say that the function value f of a is a local maximum value if f of a is bigger than or equal to all the other y values if we're close to a, in some neighborhood around a. Okay, so in this case, we say that f has a local maximum at x equals a. So this is my local maximum. That's one local maximum. This is another. Any local maximum has 2 points, 2 coordinates, right? The coordinates of this point would be a, comma, f of a, right? So there are 2 pieces of information for any given local maximum. When you're asked a question about finding a local maximum, you have to be very careful about reading what they ask for. If they ask for the maximum value of the function, they're asking for f of a, because f of a is a value of the function. Okay, if they ask where a local maximum occurs, they're asking for a, the x value. So we have local max value, or min, right? Because a min is just the reverse, just a low point. Okay. A local max or a minimum value is the y coordinate. It occurs at the x coordinate. So if they ask for the value of the maximum or the minimum, you give the y value. If they ask where the maximum occurs, you give the x value. So the wording is very picky there. They're very precise with our textbook and in WebAssign about which one is which. So just really write this down, underline it. A local max or min value is the y coordinate, and it occurs at the x coordinate. So this picture can help you remember that the max value is the y coordinate, okay, f of a, and it happens at x equals a. Yeah. Uh-huh. Yeah, there'll be like 2 boxes. You know, they'll say find the local maximums or something like that. Yep. So for example, here's a function, 4 minus x squared. I want to identify any local maximum and or minimum values, and also state the x value at which each one occurs. Okay, so what is my maximum value for this function? It's hard to tell by looking at the graph, but can you tell from the formula? Looks like the y-intercept, right? And you get y-intercepts by making x 0, so it's at 4. So this function has a maximum value of 4 at x equals 0. It's very tempting to just write there's a maximum at 0, 4, right? And give the point, because all the information is right there in the point, but you have to separate it between the value and where it happens. Okay, you do the next two. Okay, so does this function have a maximum or a minimum? A minimum. So this function has a local minimum value of what? 0. It occurs, yeah, at x equals 2. Right. Now what about this one? Does it have a max or a min? No. This function is always increasing. It's always getting bigger from left to right. So if you're always getting bigger, you can't hit a maximum value or a minimum value. So this function has no local maxes or mins. Okay, so now a little practice interpreting a function. So this is a real-life function that models the maximum number of cars that can safely travel a particular highway at a given speed. So we're going to assume that each car is 17 feet long and will travel at a speed of s. So that's going to vary. The speed of the cars on the highway is going to vary. And we're also going to assume a safe following distance, which maybe or maybe not is a fair assumption, right? So she finds that she can model the number of cars that can pass a given point per minute is modeled by this function of speed, right? So depending on how fast cars are traveling, she counts the number of cars that go by a particular point on the road every minute and found that this is a good model for that. So what do you expect? If cars are traveling very slowly, how many cars do you think will pass a certain point every minute? A lot or a few? A few. If we're going pretty slow, a few, right? And as we speed up, how many cars are going to pass that point per minute, more or less? More? Until, what do you think? Yeah, until that safe driving distance starts to make the number of cars that can pass that point makes them really far away. Because if you're driving fast, the following distance gets longer. So fewer cars are going to be going by this point every minute. Okay, so let's take a look at this graph and see if it matches the intuition that we just thought about. So we go to y equals, and I'm going to put in this function. I have to be pretty careful when I'm entering it into the calculator because there's a lot of parentheses and order of operations things. It's a fraction, so I'm going to put parentheses around the whole top and the whole bottom. Because for us, we automatically do that sort of in our brains when we see a function like that. We automatically treat it like it has parentheses, but your calculator doesn't know that. So I'm going to put parentheses 88, and I don't have an S button, so I'm going to use X, right? My variable will be X. Divided by 17 plus 17 times X over 19 squared, close parentheses. Okay, so your function needs to look just like that. So before I can actually look at a graph of it, I have to decide what kind of a window makes sense. So remember, X or S is representing speed. So what speeds make sense to put into this model? Speeds of a car. What's the slowest I should put in? Well, yeah, that might make sense to put in 50, but let's, like, in terms of just, what's the absolute slowest a car can go? 0. So let's put in 0. And then what would really fast be? Like 100? I mean, a car might occasionally go faster than that, but I think 100 is a reasonable amount for us. And then the number of cars that go by a particular spot in a minute, this we're just going to have to guess a little bit. 0 makes sense as a lower bound. No cars go by. And then we kind of just have to guess. I don't know, 50? That would be like less than 1 a minute. So I don't know. We'll just guess there and see if we have to change it. So once you have the window in, hit graph. Oh, that seemed like a pretty good guess. So that does match our intuition of what we thought. We thought that the faster the cars go, the more are going to go by a particular spot per minute, until a certain point when the following distance makes it so that you can't have cars go by that fast. So I'll take a picture of this so I can draw on it. All right, so the domain and the range of this function. So we talked about domain and range last class. Domain is the set of all inputs that you can put into the function. So what values make sense to put into this function? The s values or x values. Zero to infinity. Yep. Technically, it's infinity, even though practically there is probably some upper bound the car cannot go faster than. But so practically there's some upper bound. We don't really know what it is though, and we could, I mean, if a car went 500 miles per hour, we could try to plug it in there and see what would happen. So that's its domain. And then what's its range? Take a look at the graph. What's the maximum number of cars that can go by this spot? Yeah, it's somewhere around 50, right? The highest y value we get out of here is somewhere around 50, right? I don't know what exactly it is, but we could have 0 cars go by up to some maximum, and I'm going to show you how to get the calculator to find a maximum value for you. So pull this back up. To find a maximum value, you go to the calculate menu, just like we do to find zeros or intersection points. And you see there are 2 options, minimum and maximum. So we're going to use the maximum option, option 4. And it asks for a left bound and a right bound and a guess, just like it does for the zeros. So for the left bound, you just have to put the cursor anywhere to the left of that maximum. Oops. And then for a right bound, you just have to put the cursor anywhere to the right. And then guess. Put the cursor somewhere near the maximum point. And it says that my maximum happens at 18.999996, which we could round to 19, right? And the y value is 49.18. And this is 19. So my range is 0 to, say, 49, because you can't have part of a car. My range would be 0 to 49 cars can pass this marker on the road in a minute. All right, so I want to evaluate n of 35. N of 35, so that means apply the rule n to the number 35, remember? So into my formula, I'm going to replace the S's with 35s and calculate this. So I can get my calculator to do it quickly. If you go to the table, you can type in for X, type in 35, and it'll give you Y, 41.239. So N of 35 is 41.239. Now to write a sentence explaining the meaning, you have to remember that 35 is an X value and 41.239 is a Y value. And what do X and Y represent in this problem? X represents speed. So this is a speed. And Y is representing number of cars. So somebody put this into a sentence for me. You got it. At 35 miles per hour, 41.239 cars can pass the marker in a minute. Yeah, whether you round or not is, I wouldn't say that one way is more correct than the other. The model predicts exactly this many cars, but that doesn't really make sense. So probably 41 or 42, or maybe it's sometimes 41 and sometimes 42. So that's sort of just a downfall of using a mathematical model, is that sometimes it will give you something with a decimal, and that doesn't really make sense. So let's look at our graph again. Just copy it. So for what values of S is N decreasing and increasing? Close. So the coordinates of this point were 19, 49 approximately, right? So this function is increasing on what interval? Starts at 0 until when? To 19, right? You give X values when you talk about increasing and decreasing. And then it's decreasing on 19 to infinity. So if I want to put these in context, I would say from 0 to 19 miles per hour, more and more cars can pass the point on the road. But once you pass 19 miles per hour, fewer and fewer cars can pass the point on the road. What is the maximum value of N? 49. The maximum value of N is 49. At what S values does that maximum occur? 19. It occurs at 19 miles per hour. So the maximum number of cars that can pass my marker on the road in 1 minute is 49. And that happens at a speed of 19 miles per hour. So that finishes up class 16. I have an activity that I want you to start. This is probably the most important activity I'll give you this semester. So start it now and make sure you look at this later. It's assigned for your homework, though I won't collect it, but this is really important to spend some time thinking about these problems.